Okay, so good morning. I know there were a lot of documents that asked you if you wanted to save, and all of those should be new with the exception of that Unit 4 one you may already have. It is different, though, than the one that I've shared with you guys in previous Class Connects. It has some actual screenshots from the course. So if you clicked that you didn't want to save those and you do, you could go up to the Window menu and go to File Transfer Library, and then you can save those if you want them. I will be putting them in doc sharing. I don't have them there quite yet, but I will put them there also. So lots of stuff for Unit 5. There's going to be lots of info coming at you, lots of formulas and things, but we will go through it and sort it out and make it clear. But first, we're going to finish up the Unit 4 Part 2 review. So I think it was Will, yes, we'll put the answer for angle IJK up here, and he wrote that it was 90, which is correct. Can you tell us how you got that, Will? Maybe let us know what the formula was called, if you guys remember, or maybe describe it. I'll give you whiteboard and mic privileges if you want it. Excellent. Okay, so the reason that is, if you take a look at this circle M, KI passes through circle M, so it has to be a diameter. The angle that we're looking at here is inscribed in the semicircle. So if you have a diameter, KI is the diameter, you know that this section of the circle here has to be a semicircle. And if you remember, we had a theorem that said if you have an inscribed angle in a semicircle, and this one kind of looks like point J touches right in the middle, but even if it was not in the middle, even if it was over to one side, it would still be 90 degrees. Okay? Yes, it is. And so definitely, that's why I keep sharing all those formula sheets with you guys so that you can go back and reference. If any of you have created your own formula sheets or you find formulas that you think I should add to those, if you would send me a email and let me know, I would love that because you guys are going through it and you can let me know, hey, Mrs. Williams, I think this would be helpful. Okay. Yes, it is definitely a big puzzle piece, and as you know with puzzles, sometimes they can take a while. So definitely, get started on the Part 2 this week so that you're able to get it in by Sunday, because it definitely can, depending on, and that's kind of the thing. If you get stuck and you can't see it, one, you can come to tutor time tomorrow at 9 and I'll give you some hints. And two, take a break and come back and look at it, because a lot of times just that fresh look at it will help you out. Okay? All right, so that's that one. Let's go to the next one. This is Part C. I skipped Part B, so I'm not going to do every single letter for you. But what formula here is going to apply? You guys write the formula on the board or take a screenshot of it and put it up on the board, type it in the chat. What's the formula here that's going to help you? Good. Yep. So we had the formula that said if you have two chords, so that's what we know about EL and OF, that they are chords. Remember, chords are just segments where the endpoints are on the edge of the circle. If you have chords that cross each other, then the pieces of the chords, so note how Ben said EP times PL, okay, so right here where they cross, that chord EL gets broken into two segments. So you take those two segments, EP and PL, multiply them together, and it's equal to the other two segments, the segment pieces. Okay, so I'm not going to finish it from there, but I will give you guys that much. But from there, you just have to plug in and solve. So pretty much if you have this formula, you're going to be good to go on part C here. Okay? All right. On this one, okay, so if you see this strange symbol on the test, they meant to say arc, OLH is what that's supposed to be. Okay, so this says find the measure of angle OFH. So let's highlight OFH. OFH, that's the angle we're looking for. If you know arc, OLH is 178 degrees. So remember, the arc is the degree measure of the edge of the circle. So what's the relationship there? What would you call OFH? What kind of an angle is OFH? It has the end point or the vertex on the edge of the circle. What kind of angle is that? Good to have that. It's inscribed. Okay, so you want to look at your formula sheet for your inscribed angles. Good, you guys got that. Good. Okay, what's the relationship between the inscribed angle and the corresponding arc? So notice how this arc touches the angle at the end points. Good. Yep, so if you call the angle measure X, then the inscribed, or the measure on the edge of the circle is 2X, right? Good. Yes. Okay. So this one's a little tricky because either you'll multiply it by 2 or take half of it. And getting that right is sometimes the tricky part. How would you want to set this one up? Yes, you're right, Tristan. You want to take half. You want to divide by 2. Excellent. How could we make a little algebra equation so that that's really clear? You guys are correct. You want to take half to get angle OFH. Okay, that's good to think about it that way. So Tristan just remembers if you know the measure of the arc itself, which we do, so this is 178 over here, he just has remembered, okay, then you take half to get the angle inside. That works. Can anybody set up a little algebra equation for this? What would I do with the 2x and the 178? That's kind of what I'm going for. What's the relationship between those? Okay, true, Ben. Still not quite. Now, everything what you're saying is true. I'm just trying to get you, can you guys make an equation out of these two things, the 178 and the 2x? What's the relationship there? And what you have been, it really is that relationship. But I'm just trying to, I think some students are going to want, it'll be more clear if we can make an equation out of these two. So, there, Nora, you got it. There we go. That's what I'm trying to say, trying to get you guys to think about. 2x and 178 are both the measure of the arc, and so they have to be equal to each other. So if you just think of it that way, okay, first just label, okay, my inscribed angle is x. The measure of the arc is twice that, 2x. And then put on what you know. Either you'll know the arc or you'll know the angle. And whichever one you know, make it equal to the x or the 2x. You know, whichever one is if you know this is, if you know the measure of the arc, set it equal to 2x. If you know the measure of the angle, set it equal to x. And that way, it's kind of like a no-brainer. If you just solve this, then you will take half of the 178. But then you won't get confused as to, do I take half or do I double it? Which one is it? Okay, so if you just set up your little algebra equation, then that will help you sort it out if you're kind of struggling with that part of it. Okay? All right, I think this is the last one. Again, they have a strange looking symbol. What they mean is arc. So the measure of arc OL and the measure of arc EF. So again, on the part 2 test, if you see the strange symbol, they're really just put an arc over that. That's what they meant to do, but it didn't copy in the Word doc for some reason. So we want to find the measure of arc OL. So let's highlight that, just because there's a lot going on in this picture. So that's what I would suggest. One thing that might help is to really, you know, grab your colored pencils and color code and see if that would help. Okay, so we have the measure of arc OL. we're looking, or we have, or we're looking for the measure of arc OL. We have angle OPL, and we have the measure of arc EF. Okay, so any ideas on how we could find this one? And you have mic privilege and whiteboard privilege and chat privilege, so let's see if we can figure this out together. Yes, Tristan, so you're doing what I think a lot of people are going to do, is kind of try to eyeball it. But I will rule that out for you. It is not 30. Good, Ben. What formula are you using there? That's the right setup. That's where we're going. That's where we're going from. Or maybe if you have, I don't know if you're using that formula sheet, maybe if you could tell, if you are using the formula sheet, tell us which one you're using there. I know it's kind of hard to describe because they're not numbered. Okay, so does that one look more like one of these? Look familiar? Is that what you were using, Ben, one of these? Yes, excellent. Yep, it is going to be 68. But in order to get credit on this test, I want you guys to show your work. So let's work it out. So we know that OPL is 49. How is it going to help us? So if you look at the formula I copied on, this is from that formula sheet. It's the bottom of the first page. If you look at angle 1, for example, or any of these angles, the pattern is the same. You're going to take the arcs. So if you look at the chords here, okay, you have two chords that are forming angle 1, for example. And where those chords intersect the circle, there are arcs that are formed. So arc AB and arc CD. So if we look at this angle, and we look at the chords that make up that angle, you have chords. Okay, so we look at chord OF and chord EL. Where those chords touch the circle, there are two arcs created, arc OL and arc EF. There you go, Tristan. Yeah, now you guys are starting to see it, okay? So we would say from our picture, using the pattern below, angle OPL is equal to half of the sum of the arcs. So arc OL and arc EF. Do you guys see the pattern there? This one's kind of tricky. That's why I tried to kind of put some that I thought you might struggle with a little bit. Just because it's kind of hard to see what the pattern is here. So the pattern is, like, if we look at angle 4, for example, you're going to take half of arc AD plus BC, and that's going to equal angle 4. Or if you wanted angle 3, you take half of arc BC plus arc AD. Okay? Yeah, and then we plug it in, so we know that angle OPL is 49. Oh, and you know what I should do here? I'm sorry. measure of arc OL and measure of arc EF. I need to get my notation correct there. I know it's hard to type in the chat, so I know what you guys are saying. So the measure of arc OL we are looking for, I'll put an X there. The measure of arc EF we know is 30. Okay, and then you're going to solve that. Now the easiest thing to do to solve that, you could distribute the 1/2. To make it a little easier and get rid of the fraction right away, you could multiply by 2 on each side, because then the 2 and the 1/2 are going to cancel out. Okay, so yes, excellent, and that's where Tristan's getting that 98 from. So we have 98 equals x plus 30, and then subtract 30, and then you get the 68. So x, or the measure of arc OL, is 68 degrees. Okay, do you guys see that now? Any questions on how we got? Once you get this set up, I think you guys will be fine, but just seeing this is tricky. Okay, so I see some of you get it. I'm not sure about it. How is overall the class feeling? Can you give me a smiley face or a frown face? I know Nora